Let's derive the Rutherford scattering formula. So in this situation we have a very heavy charged particle. Let us suppose it has a charge capital Q, and we throw a lighter particle having some charge, let's suppose small q, with some speed v0. Now the separation between the line of approach and the heavy charge is known as the impact parameter. Let us call that as sums small b. Now we need to find how much is the deviation that is caused due to the ensuing repulsion that keeps on acting on this charge. Now as we can see, the charge was approaching along this direction. This is the initial velocity vector, vi vector, and after interacting with this heavy charge capital Q, it ended up moving in this direction. Now the initial and final velocities are being defined when the particle is very far away. So by energy conservation itself, I can safely say that the magnitude of this velocity will also be v0. Now we are bothered about how much this vector rotates. Now initially it is pointing in this direction, finally it is pointing in this direction, and this line is our symmetric line. So this is the basic diagram for the situation. Hence we can easily see that this angle must be our deviation delta. So this delta is what we need to find out. Now from the symmetry of the situation, I can also see that these two angles are also equal, which is same as this angle. So therefore any one of these angle could be written as pi minus delta divided by 2, because the total has to be pi. Now if I apply the impulse momentum theorem, so we can clearly see that effectively I have a vector of length v0 which only rotates. Now it rotates by some angle delta. Hence the change in velocity that happens only along the symmetric line. Therefore I can say that integral f net dt, which by the theorem must be equal to the change in momentum, is equal to mass of this, let's call that as small m, into the component of v0 along the symmetric line. So that will be v0 cosine pi minus delta by 2. Now since we are taking the change, we have to include 2 also, because the direction reverses and the magnitude still remains the same. And the direction for this impulse is along the symmetric line, so like this. So this becomes our equation number 1. Now let us write down the f net vector. This implies integral 1 upon 4 pi epsilon naught q upon, now this separation from here to here, let us suppose that separation is some r. So I will write upon r square. Now I know that only this component along the symmetric line is responsible for all the change. So now I will not bother about the net vector, but just the vector along the symmetric line. So if I call this some angle theta, so I will take cos theta here multiplied by dt is equal to 2mv naught cosine pi by 2 minus delta by 2. This implies, let's take the constants out, integral cos theta by r square, theta and r both are variable in this situation, multiplied by dt equal to 2mv naught sine of delta by 2. Let's call this our equation number 1. Now we need delta. That means if we can somehow manage to solve this integral, then we are done. Now we will use our second equation, which will come from the fact that the force always passes through the heavy charge, this heavy mass. So if I label this as my 0, 0, 0, that means the force acting on this smaller particle, let's call that as particle P, will have always a zero torque about the origin. Hence I can also say that the angular momentum of the particle P about 0, 0, 0 must be constant. Now that constant is obviously, if you look at the t equal to 0 situation, is mv naught b in magnitude and pointing inside the plane of this drawing. So that constant is known to me. Now at general time t, when the particle is here, let us also write that angular momentum. So therefore I can say that mv naught b clockwise must be the angular momentum at any time t also, which will be the cross product of the r vector and the p vector. So that will be r vector cross p vector. This implies mv naught b clockwise is equal to rp sine alpha, where alpha is suppose the angle between r and p clockwise. Now p sine alpha is obviously, by the concept of cross product, that component of p which is perpendicular to r. So let me just write this as p perpendicular. Now that component which is perpendicular to r is responsible for changing the angle theta, as we can easily see, since this angle is 90. Hence we can write our p perpendicular as mass multiplied by r omega. Now omega can therefore be written as d theta by dt. So therefore v naught into b comes out to be r square d theta by dt. This is our second relation. Now from this second relation we can find out dt by r square, and then we can put that value in our first equation. So let us do that. Therefore we get 2mv naught sine delta by 2 equal to 1 upon 4 pi epsilon naught q integral cos theta multiplied by, now dt by r square becomes d theta upon v naught into b. Now we just have to put the limits of theta. Therefore cot of delta by 2 comes out to be m v naught square upon 1 upon 4 pi epsilon naught q divided by b. I hope this video was helpful. Thank you for watching.